Have you ever wondered why the planets don't simply fly off into space or crash into the sun? What unseen forces are at play guiding their celestial dance? To answer that, we turn to the wisdom of Johannes Kepler, a man who back in the 17th century managed to unlock some of the universe's most intriguing secrets. Kepler's first law of planetary motion, also known as the law of ellipses, is quite fascinating. It's a bit like saying, planets, you have the freedom to move, but within certain boundaries. In simpler terms, this law tells us that planets move in elliptical orbits around the Sun, which sits not at the center, but at one of the two focal points of the ellipse. Imagine an oval-shaped racetrack. The Sun is not in the middle of this track, but off to one side. The planets, like race cars, travel around this track, moving closer to and farther from the Sun as they go. This is why we sometimes see our neighbouring planets more clearly in the night sky at certain times of the year. They're not moving closer to us, but closer to the Sun, which illuminates them more brightly. In essence, Kepler's first law breaks away from the ancient belief that heavenly bodies move in perfect circles. It introduces the concept of an elliptical path, a slightly squashed circle, with the Sun off-center. This means that a planet's distance from the Sun varies as it moves along its orbit. So the key points to remember about Kepler's first law are: 1. Planets move around the Sun in an elliptical orbit, not a perfect circle. 2. The Sun is not at the center of this orbit, but at one of the two focal points of the ellipse. And 3. This means that the distance between a planet and the Sun changes as the planet moves along its orbit. Kepler's first law of planetary motion, a seemingly simple statement, reveals a profound truth about our universe. It shows us that even in the vastness of space, there are rules, patterns, and order. And isn't that a comforting thought? Even in the infinite expanse of the cosmos, we are not adrift. We are held in place by the invisible hands of physics, dancing a well-choreographed ballet around our radiant Sun.